Thank you. Thanks, Josh, and welcome everyone. I think this message is explanatory, so I apologize. This is not the visually rich, contentful version of a live book-driven presentation. This is a 5 a.m. complete rebuild in Keynote for iPad, but I hope it conveys the principles which make me interested in image processing. And I suppose if I take a step back and ask, why would anyone bother doing another image processing library, given how pervasive ImageMagick is, the well-known and understood bindings for that in Elixir and every other programming language in the world? It's a pretty fair and reasonable question. And the answer really comes in a couple of parts. One of them is, I believe that the platform upon which image is built is a far more appropriate fit for a lot of reasons to the Elixir ecosystem. And secondly, as someone who spends a lot of time taking photographs and processing images as a passion more than a hobby, I wanted to understand, what does brightness really mean? What does enhancing contrast mean? What does noise reduction look like? And so building those primitives, albeit on the scientific foundation by others, is also, for me, very, very interesting. And I suppose at this point now, a year and a half into this project, it's got more traction than I originally anticipated. So I think it's reasonable to spend some time talking about why that might be and why it might be relevant for other people. Because I think we all accept that a contemporary application today needs to be engaging, and a visual representation and imagery is an important part of that. Yet at the same time, when I look at how well Elixir and the core components of Elixir, be they Ash or Phoenix or others, create a single stack environment that's easy to develop and easy to deploy, the imaging environment across all language ecosystems is rife with many, many moving parts that don't necessarily add significant productivity for the developer, or productivity for the art director, or productivity for the graphics team. And they certainly create a lot of revenue opportunity for CDNs and image cloud providers. Now, none of that's to take away from the importance those players make for this entire environment, but it strikes me that there are a lot of applications that are not built for planetary scale. Like most applications aren't built for planetary scale. And therefore, at a certain point in time, there's a class of applications for which an integrated full stack environment can, and I would argue should, include image processing in a way which is as easy, as robust, as scalable, and as reliable as doing so with a lot of other external moving parts, particularly since those moving parts typically originated when browsers could only open 4 streams to a server, when we didn't have the capacity to be able to do image processing in real time in most cases. And now at least we have some options. Now, those options wouldn't present themselves if the only option was ImageMagick or any other image-based library which has certain characteristics. If they load the image into memory in its completeness, then that seriously impacts the memory utilization of any machine. And as a consequence, you also get the very typical CPU bumps that come alongside any of that processing. And these are clearly not acceptable characteristics of an online application. Now, not every application is a web application, and not everyone that's doing image processing is doing it for web purposes. And in fact, this LibVips technology, which is really the magic sauce here, originated and was developed by the author who worked at the time for the National Gallery in the UK, doing, you might have seen these on various engineering shows, gigapixel scans of famous works of art. And if it's already difficult to take 1600 by 1200 images, load them into memory, transform them, and produce an output on a typical online application, gigapixel images clearly have a whole different set of dimensions, and it may simply be physically impossible to load those images into memory in the first place. So our objective, my objective, is to leverage the great work that he has done with LibVips, built upon by Vix as a NIF bindings to LibVips, and deliver with image and idiomatic API for Elixir users to make that happen. So Mine's just the shiny stuff on top of some incredibly fabulous work by other people. And if as a result, I can make image processing an integral part of application development that meets the needs of a developer and an art director and an image processor, and deliver a real-time capability with adequate performance and manageable memory footprint, then I think that's an advancement. And of course, if you disagree with those principles, that's totally okay too. There are alternatives that you can use. So what makes Image, the library that I've built, a difference? And that difference, as I've explained, is because it's built upon a library, LibVips, that takes a quite characteristically different approach to how an imaging pipeline is implemented and executed. And Vix is the NIF bindings that link LibVips to the Elixir world. And because of how LibVips is written, Akash, who writes Vix, has been able to fully introspect that API. So the NIF itself is generated from the LibVips binary, which means that having done all of the hard work, when new releases come along, all of the functionality that's available to it becomes automatically available to the Elixir world. The second thing which appeals to me, and I think this is an overall characteristic in general of the Elixir ecosystem, is that the authors are responsive and engaging. Responsive doesn't always mean you get what you want, of course, but no is the second best answer you can get. Getting an early no at least means you're not waiting for something. But to be fair, John Coopert and Akash, who does Vix, are incredibly engaging and very responsive, and it makes building image just lots of fun. Why the architecture works well for image processing is that it's quite functionally oriented. It is designed to build imaging pipelines, operations which are immutable and horizontally scalable. And that sounds an awful lot like the Elixir world and has the commensurate benefits. There are the majority of operations which fit very nicely into a world in which the image itself is immutable, in which the operations can be chained, and in which the execution can be made concurrent. There are a few cases where that is not perfect. If you want to work at an individual pixel level and be doing individual pixel munging, this is not necessarily the best way to be executing. But I think in a significant number of use cases, that's not the critical requirement. There are a few other aspects that make this really interesting for non-traditional from an image processing point of view. For example, the way that LibVips and Vix are built, it becomes trivial to create a binary interchange between image and NX and image and eVision, where eVision is the Elixir bindings to the OpenCV library. And there are, for anyone that is engaged in machine learning and image segmentation and object identification, in QR code generation and decoding, these are really valuable attributes of any imaging system. And there are significant opportunities where image plus NX or image plus eVision enhance and mutually support each other. And then I think just to make it really, really obvious, these are native bindings through NIF technology, not opening a port to an additional shell command over which we have limited control and limited confidence, I would say. In fact, if I take a look at the CVE database, and I'm not poking fun here at ImageMagick at all, but it is an important consideration for any software we write and use. There are significant unresolved CVEs for ImageMagick, and 670 of them in total as of this morning, whereas LibVips has 9. Now, the user populations are different, the application domain is different, but nevertheless, I know that the authors of LibVips spend considerable time in ensuring the quality of their code, the security and reliability, and managing the resource utilization in order to mitigate the traditional attack vendors of image processing. So that's what makes image as a library different. It builds on an incredibly solid foundation, but delivers an idiomatic Elixir experience. So I've said that it's demand-driven and horizontally scalable. What does that mean? Here's an example of a quite typical, fairly small image processing pipeline. There's an image which we open, we thumbnail it, which is the function most notable for resizing an image in LibVips, Vix, and image, rotate it, change the contrast, and write it out. If I was to ask you at what point in this pipeline would you expect to see memory utilization and CPU consumption, what would be your normal expectation? If you are running a eProf graph or running Observer, when would you start? It's actually not Elixir memory, but work with me on this. When would you see memory consumption and CPU utilization? Well, since everyone's really reluctant tonight, that's okay. The answer is that actually nothing happens at all until it needs to happen. This is the essence of demand driven. So in the live book that you will eventually get to see as soon as I get my computer back, you'll see a running graph of the high watermark of memory that's consumed by LibVips. It uses Google's glib underneath, and you've got metrics up the wazoo to be able to measure consumption and performance. And you'll find that in this situation, nothing actually happens from either a memory allocation point of view or execution until it needs to. And when does it need to? In this pipeline, when you write the image back out to disk. At that point, all the pixels need to be materialized that reflect the operation. Now, this has some significant benefits. First of all, these operations can be made concurrent. The default in LibVips is to use the same number of cores to create the same number of threads as the number of cores you have. If you're running a real-time web app, you'd probably want to tune that down a little bit to leave some time for something else. But that concurrency is really, really valuable. The second thing is you'll notice here that the first operation is to thumbnail, to reduce the size of the image before rotating and applying contrast. Because it's demand-driven, that means that rotate and contrast are only operating on the reduced number of pixels necessary to instantiate that 200 width pixel. And that has significant positive performance improvements, because we're no longer loading the entire image into memory. Maybe it's a gigapixel image, sizing it down to 200, and then performing the operations. Because in many cases, and I'll explain this momentarily, the opening and reading of the image can build in a block resize function that means the gigapixels never actually even hit memory in the first case. It's able to do a block resize. So this looks a lot like idiomatic Elixir. This has the same concepts that we're used to. A pipeline of transforms that can operate in a concurrent fashion. And this contributes significantly. You can also set the maximum amount of memory that you'll allow LibVips to take, the maximum number of threads that you'll allow it to execute, and that gives you significant control over the performance characteristics and the resources you're willing to dedicate. So I think all of that is a positive. The second thing I said is that images are immutable. There are, of course, a couple of exceptions, but you need to work really hard to use those exceptions. And I'm not really going to spend any time on those, because if you're going down the path of mutating an image, you're probably using the wrong library for the wrong reason in this world. But there are some limited capabilities. So in the example here, if we look at these, you'll notice that there is no operation in either of these two pipelines that would require the instantiation of anything. In fact, if you typed these into IEX or put them in a module, no memory would be allocated, no CPU cycles would be consumed. You would simply be defining some image pipelines. But you should recognize that at each stage, but most definitively, if you were to compare image to other image, they would, of course, not be equal. They have different transforms, but at no point in time is memory being modified in place in the production of these images, at no time. So there's no issue with mutexes and locks. There's no needs to worry about managing shared memory. These are imaging pipelines that transform pixels on the way through, and those resulting pixels are then, you do something with them or do nothing with them. If you decide that after you've done the image contrast, that there is something wrong with what you've produced and you never save it to disk, or you never send it down a WebSocket, or you never store it in AWS, you will have consumed nothing, which I think is a really positive element here. And as a consequence, in order to preserve the integrity of that functionally oriented, horizontally scalable and immutable environment, operations are matrix oriented. So I typically get questions saying, well, I want to get this pixel to do something with that pixel. And there may be many valid reasons for doing that. But typically, the higher level abstractions are implemented as matrix operations, but not matrices which are resident in memory. They operate on regions that are demand driven. And I know that I'm overemphasizing this, but it is a critical understanding to explain why the resources that are required by LibVips are significantly constrained in comparison to an ImageMagick or other capabilities. It also means, as a result of these operations being quite high level, that there's just one NIF call to make those happen. And since the memory itself that represents the image is only ever maintained in the NIF and is never transferred unless you specifically ask for it to Elixir, then memory management is also automatically managed both by glib on the LibVips side and automatically reclaimed by the Erlang garbage collector, because it's completely built into the image, into the garbage collector. And that can do that because there is a guarantee that there's no mutation occurring to that memory space. So whatever image you create, the Erlang garbage collector can garbage collect. You don't have to worry about it, which saves a significant amount of risk in any activity. The most common thing we do with images is to reduce their size from some large 45 megapixel picture down to 1200 by 16, whatever it is. This is so common that there is a significant amount of optimization built into LibVips to make this as performant as possible, performant and constrained in resource utilization. So this, for anyone that's going to look at doing some image processing, it's not obvious enough from the documentation on my side, but it is strongly recommended that you pass the image path, if it's on a file system, directly to the thumbnailing operation, because LibVips can do a block reduction during the reading of the image, and therefore you have very little memory consumption because you're not reading the image in and then resizing it. Opening the image first and then resizing it is not recommended. I hope that's obvious enough, but ask me a question later if it's not. So, yes. Yes, because it was 5 in the morning and I'm rebuilding a presentation that I'd already built. So good call. I'll go change that. I'll also show in a moment why it's not always possible to do it this way when we get to image streaming, but thank you for the call out. So I said the images are only instantiated on demand, and typically in an image processing pipeline, only the region of the image necessary for the operation is instantiated. So if you are overlaying images, if you are changing contrast, selecting regions, doing segmentation, you're only working on that part of the image, and the rest of the image doesn't need to be memory resident to make that happen. But there are certain circumstances where you simply need to load the whole image into memory because it's being passed to some other environment. One of the most common places that might be passed would be to NX, if you're going to do any of the machine learning models on imaging data. This is, of course, an increasingly common requirement. In these situations, the entire matrix needs to be loaded into memory because that's what NX expects, and it's going to pass that imaging data and the NX pipeline to the GPU or to some other back end. So here's an example of what that looks like. I'm creating a new image. It's a very small one so that the example works, transmitting the image to NX, and then the result we get is an NX tensor. I just want to explain a couple of things that happen here so it's really, really clear. The memory that represents the image is never passed to the Elixir environment. It's simply a pointer reference in the NIF being passed from LibVips to NX. That's it. So it's a zero copy. The image has to be instantiated because LibVips doesn't normally do that. So it's instantiated into memory, but not Elixir memory. It's C binding memory, and the pointer to that memory area is given to NX. Now, since we're operating in an immutable world, NX is now responsible for that piece of memory. It's no longer associated with LibVips, which means the garbage collector can still do its job. It just happens that it's now going to be garbage collected in the context of NX, not LibVips. And this can happen for an arbitrary sized image, as long as it complies with typical imaging requirements. It's got a height, it's got a width, and it's got a number of dimensions, typically 3 or 4, or 1, typically 1, 3, or 4. But it might be 5 for a CMYK image or other things. But of course, on the other end at NX, it also has to be consumable by NX. So typically 1 band or channel, or 3 or 4 if you've got a transparency layer, an alpha band. And exactly the same thing happens with eVision. Now, when I say exactly, there are some representational differences, but they are representational, same memory layout. So for example, in image, because it's designed around how people think about images, the X and Y dimensions start at the bottom left and work up. In NX, it's more matrix oriented, so it starts at the top left and works down. So that's representational. The memory layout doesn't have to change, but how the axes are described has to change. That's taken care of in the 2NX core. In eVision, for whatever reason, I did read the explanation, but I didn't understand it. OpenCV uses BGR order for the colors of an RGB image, whereas most image processing uses RGB. Again, so there is some work there to move the color representations around as well, but you don't need to worry about that. That's all taken care of for you. So we've looked at immutability, we looked at horizontal scaling, we've looked at interoperation with NX and eVision at least the basic level. What else might we consider? I've very deliberately not focused on basic image operations like brightness and contrast and so on. Those I think are well understood operations that you expect to be there. But because we're in a functional environment, kind of, then composition is more important than mutation. So using this example, how might we construct this image? It's composed of several different components. So let's take a look just at how this works. So we first of all need to build the underlying individual elements that we're going to lay out on top of the base image. This also gives some clue of the kinds of operations that you can build in image, again, on the top of Vix and LibVips. The first shape is a polygon. Polygon is the blue polygon, light blue, slightly transparent background. So polygon color and the various attributes. This is using an SVG renderer underneath. So describe any shape you like. When you say in image terms, just open an SVG string, and it'll take care of the rendering associated with that. The second 2 or 3 here are all text type images. So that's pretty important. You can see this is a large white text, smaller white text with a white border around it. And that's the following images after that, with reasonably capable text markup, not fully fledged. Don't do everything that you want. If you need to do that, then you'll need to still mark it up in some other tool first, but pretty reasonable text markup capability. It uses libpango inside libvips, which has got a kind of HTML-like syntax if you want to do that kind of imaging. So now we've got the base image types. Now we can compose those images together. There are 2 ways to do that. They have their own relative merits. The most idiomatic Elixir approach is simply a pipeline of compositions. So each step in an imaging pipeline produces another image, because all images are immutable, and every operation produces a new image. So in this case, we're taking the base image and composing those 5 other images over the top of them, stating where the overlay is to occur. In some cases, it's easier from a design point of view to think of the relative positioning. So if we go back to this image, you can see that there's one and another one underneath and another one underneath, like that. So in this situation, it might be easier to say, compose the polygon, then relative to the polygon, put the next image, and relative to that image, put the next image, and so on. So 2 different ways that you can approach composition from an image point of view to make that happen. All of that compiles down to the libvips, much more primitive operations to make all of that happen. So composing images is probably the most common feature for anyone that's interested in art direction to create marketing output, not simply just representing pretty pictures on a web page. And you can go a little bit farther, and I just really enjoyed putting this example together at the time, because you can work with transparency in those overlays. Here's an example of creating transparent text with a slight opacity with respect to the background. And you can see it's no more difficult than describing the text correctly and composing one image over the top of the other. And on a full screen, on a big screen, this actually looks quite looks pretty good in my opinion. So immutable, horizontally scalable, functionally oriented, so composable, allows us then to look at, well, how do we apply that in a more online world? One of the common operations every application faces is, how do I upload an image? How do I transform it and store it? How do I serve it appropriately to whatever the end use happens to be? Now, image is not yet a complete solution for all of those steps, not by any means, but at least the basic fundamentals are in place to allow that to happen. So because these images are demand-driven, integrating them with Elixir streams is actually really straightforward. A little bit of work by Akash in Vix to build upon the primitives of LibVips, but now you can stream, you can do file.stream into an Elixir imaging pipeline. You can stream an image into a plug.con for a web application, and that opens up all sorts of opportunities. Here are some typical examples that are all built upon Elixir streams, or if not strictly Elixir streams, plug.con chunk responses or chunked uploads are also interpreted correctly to make that happen, including, of course, AWS streams, which is for anything that's using AWS standard interfaces. And I'm really interested in how Tigris Tigris integrated with fly.io represents an opportunity for a low-cost, high-performance, geographically capable CDN for image processing as well. So what might some examples be? Here's an example of streaming a file to a plug.con. So the typical example would be an image request comes in from a web application. It's a large-ish image, so we'd like to stream that image for either network performance or user responsiveness, because time defers pixel typically becomes an important characteristics of user acceptance. If we look at the left-hand side, then it's nothing more than the typical primitives we would expect in an Elixir app. Stream the file and open it. Image.open understands how to deal with streams. Do any of the operations that you would want to do, with only really one caveat. Not all operations can operate on an image top to bottom. Some operations want to go back to different images. So the majority of operations will work in a streamed fashion like this. And really, these two examples are the same example. One of them is explicit on the left, the other one is implicit on the right, but it's exactly the same implementation underneath. So on the left, the approach to streaming in a plug.con struct is to do a reduce while and do chunking. So that'll send the chunks out as and when the plug allows that to happen. And on the right-hand side, to keep that simpler and more idiomatic, you can just do image.write to a con, and underneath it'll do exactly what's happening on the left-hand side. But the idea that I have in mind, which not everyone agrees with, I can respect, is you should be able to open almost anything, and you should be able to write to almost anything, and not have to think about what that thing is, so that if you change from a direct file write to a stream write to an AWS write, you don't have to think about that in the majority of your pipeline. You're just changing the source and the sink of the pipeline. So you can write to image.write or to a plug.con or to anything which implements the collectible protocol, whatever that happens to be. So the example from an AWS world, here is an example. This is all the code it takes once you've got the setup done for the configuration, that is streaming a file from AWS, transforming it and streaming it to AWS. This is it. Don't have to do anything else. Download the file, xaws.s3.download. That will stream the image to you into memory, chunk by chunk. Convert that to an AWS stream, which is then opened, thumbnailed, and then streamed out again. Need to give it a prefix. Don't have to give it a name, but it needs to know how to encode the image data. So you have to give it a prefix so we can work that out. then upload that as a stream and request. And it's first time I put this together and ran some tests, like that is just magic, but it works incredibly well and very reliably. And as you can see from this, the full image is never instantiated. Only enough image is loaded in order to be able to resize it to the pixel size we said here, 200, which means the maximum size of the longest side of an image will be 200, and then streamed back out again. And it works remarkably well, as you would hope. I just want to briefly go back to now looking at why some of the integrations with NX and with eVision are helpful. I've explained that this is a zero copy mechanism, but it's a fully instantiated image. There are some fascinating things that you can do. And if you've not looked at the eVision package from Coco, it is a almost full implementation of OpenCV with Elixir bindings. Also introspected and auto-generated, and I don't know how she made that happen. That's an impossible task, but it's an amazing library. Not for the faint-hearted. It's a large API, and OpenCV definitely wants the full image loaded into memory, but there are certain things it can do that are very difficult to do elsewhere. And again, the NX integration. One of the live books that are now on the repo for image is an implementation of the segment anything model from Facebook, not implemented by me, but the image approach to it implemented. And it lets you then do all sorts of crazy things to segment images and mask them. One of the things that I implemented straight into image is QR code encoding and decoding. It's not my intention to shadow the API of eVision at all. It is far too large, far too broad, and it's completely optional as a configuration for image. So if you configure eVision and image, then you'll get this capability. And if you don't, it won't be there. It's an optional dependency. But here's an example. This is all it takes to implement a reasonably idiomatic QR decoding. So take an image. So vimage is the struct. It's an alias of the struct for an image. Send it to eVision and execute the second part of the code. Call the detector, which is the eVision detector module, eVision.detector, .detect and decode. You can see the Python heritage here coming through in the function names, which is one of the reasons I chose to write a wrapper for this. Detect what the result is, and then send the URL or whatever else it decodes to back. So really quite straightforward and simple. But the OpenCV documentation and APIs are quite difficult to understand. So I thought this was a useful capability as an encode function as well that will produce for you a QR code image in an easy fashion. So I'm drawing to a close because I reckon what Nick and Josh are going to present is probably a lot more interesting than this. I've been working on this for a year and a half. It's at release 0.45. I am primarily enhancing image by user request. There are an infinite number of things you can do in image processing. By now, I think most of them can be implemented by composing the functions that already exist, but I'm always very open to introducing new capabilities that meet user demand. So that's my primary roadmap for image. Tell me what it is you need. If it can't be done, I'll find a way. And if it can be done, I'll do it. What's stopping me go to a 1.0 release is that the color model that I've got implemented is not nearly flexible enough. It has far too many assumptions about images being RGB when they don't need to have that assumption. So that's probably going to take me another quarter to do. So by Q3 calendar, I should be in a position to do an image 1.0 release. There are some future developments because I said it's not a fully fledged solution for someone building web apps that wants easy uploads, transformations, caching, and distribution. But I care about that. I think that's a very interesting topic. Most people say to me, just give that to a CDN and you're taken care of. For some reason, and maybe I'm bloody minded, I don't think that always needs to be the answer for many, many apps. So I have additional libraries that I'm working on, but I'm working on them pretty slowly at the moment, it's fair to say. The first one is to have a URL-based image transformation API. There are hundreds of APIs I could choose, but I'm going to start with the Cloudflare image API because it's primarily oriented around recipes, and I think that's the right model personally. So you build a recipe that says what the transformation looks like. Here's what a thumbnail looks like. Here's what a hero image looks like. Here's what a spread centerfold looks like, and so on. Upon top of that, I'll do an image.cache plug so that you can cache those image transforms and send them. And then the tricky bit, which I don't think I have the skills to do, so I'm certainly looking for collaborators, is to build a functional image component that can make it really easy to define the image that you want in a responsive fashion that can meet modern web standards and can simplify the development cycle as well. And then lastly, the one that I feel most confident I can do myself is what I find interesting about Tigris is that it's an AWS S3 lookalike object store, great for storing image repositories, that's deeply integrated with fly.io. So that's a pretty popular deployment choice, but it will do automatic geographic distribution of those images, which has many of the benefits of a CDN, but not all of them. So that's definitely near and dear to my heart, and I expect to be able to do that in the next couple of months. So that's all from me. I've got no idea how much time I took, Josh. That's pretty appalling of me, but I'm very happy to take any questions now or over beers, depending on who's online.
Yeah, I have one. What does bang make?
What does bang mean?
Oh, exclamation mark.
Typical Elixir meaning, which is you'll get a successful result or it'll raise.
Okay.
So there are bang and non-bang versions of all the operations.
So you said you're discouraging.
Yes.
That's about set up the source. It doesn't do anything to define sync. Would it be possible for you to define the transformations and then have the source and the sync be the last two operations of the pipeline? If you did that, would that then solve your documentation problem? Was that be?
You do need an image object upon which to base transformations. So there has to be a base image to start with in order to make that happen. So back to this one. So image.thumbnail needs to work on an image on an image struct. So the result of opening or creating a new image.
So
because it's doing exactly that. It's taking the path. Underneath, if you pass image.open a path name, it calls a function in LibVips called thumbnail, which takes a path. If you give it an already open image, it's going to call thumbnail image, which is a different function. So actually, it's two different functions under the cover. I may be occasionally accused with good justification of trying to oversimplify a developer-facing API, but I wanted to make it as easy as possible to change the source and sync, but not have to change the rest of the pipeline. So this is more cautionary than anything, because clearly, as you would have seen, if you're streaming images, which is a lot of what we do, then it's not possible to pass a path name. You're dealing with an already open stream, so it is what it is.
But if we were following your reasoning, so you've done it this way because it's like the other stuff. If you take that a step further, you change your API to match your way of thinking things and set up the transformations first. So you just have only part of it, just have thumbnail, contrast, blah, and then finally define the source and sync. If that would then sort of resolve some of the issues we've got with the strong stuff.
Yes. There are some complexities there, but I will be doing very close to exactly that with a HTTP parameter-driven version, because I will do operation reordering in order to make sure that that they are in the optimal order to minimize the window of the demand necessary to produce the result. So in those circumstances where I'm controlling both the order and the source and sync, I can do that reasonably straightforwardly. But it is more difficult in this case because the pipeline itself needs to have an image reference. Unless it is some very significant restructuring, which I'm unlikely to do.
Significant restructuring, but you know what transformations to do. So you can create the transform pipeline and then only create the underlying structure.
It's a fair point. It's a fair point, but I'm more likely to go with the strongly enhance the documentation approach.
Why would you use image open at all if it's that much slower?
Because if you're streaming from a file or AWS, there's no path to open, you're getting a chunk. And that chunk still needs to be represented as an image object or an image struct. And the way to do that is to open it.
So in the streaming world, it's got to.
In the streaming world, you have to open it. Because there's no path to disk.
Questions online, mate?
Yeah, we do. One from Theo. He noticed one of the slides, you specify a font face. Where are these loaded from? Do we have to include a file somewhere in the repository and configure it?
So it relies upon the system fonts, and it uses please, I apologize in advance to Windows users. If you do fc-list on your system, and assuming it's a Mac or a Linux system, it'll list for you the system fonts, and that's the API that's being used to resolve the fonts and the font name and the font file if you don't specify the font file separately. So you don't need to do anything if you're using the system fonts. If you're sourcing third-party fonts, then you need to specify the font file if it's not already represented in the system.
Mm-hmm. Great, thanks. And a couple from Rob. Can you clarify what is a block resize?
Yeah, I was afraid someone was going to ask me that. I don't know the specific details, so I'm not going to bullshit you, but it is a mechanism. When I speak to John Cupid, who is the author of LibVips, it is a mechanism by which, when in opening and reading the blocks of the image off the disk, they can be resized as they come off disk, as opposed to coming into memory, then being resized and further transferred on. And in his experience, this can be often up to 10 or more times faster than opening the image first and then processing it.
Naively, wouldn't that just be read the right bytes file at the right offset? So,
Logically, that makes sense, but I've got no proof to back that up. But I'll take the question on notice because I've always been curious, but never spent the time. I will find out more. And I'll add a footnote to these slides, Mike, before I send them to you with the reference online.
any other ones, Mike? We brought over the second one. We got time for one more.
Sorry, did we have a network dropout there?
I think you said Rob might have had a second question.
Yep. Okay. Is there support for converting to PDF?
I will give you an affirmative. I will give you a definitive answer before the end of today's session.
No, it's not that.
I think the answer is yes, but I haven't looked.
So if it's in LibVips, then maybe.
Yeah, no, I'll be rude to do this while Nick's presenting, but it wouldn't be quite as rude doing it when Josh is presenting. So I'll get an answer by the end of the session. Thank you very much.